Welcome back, everyone. All right, hope everyone's doing well out there. Stay healthy. All right, if you are in self-quarantine, I got a lot of videos. Okay, so some of you chuckle, but it may be you soon. Okay.
According to the mayor, there will be a 14-day.
I'm just saying, right? Let's see, the Joy School closed, St. Thomas Episcopal closed, rodeo shut down. So, just saying, we don't know yet. We don't know yet. All right. What's the first thing I have to do when I run an interval? Actually, you don't have to define the parameter. You don't do hypotheses. You go straight into the assumptions and conditions. Let's do some assumptions here. The first one, it's all good, is the paired data assumption. Now, if you look at this packet, right, this page and the next page is blank, so you've got plenty of room. So don't feel like you need to write super small. I mean, obviously, write your normal size. Okay? So, paired data assumption. So what statement can I write here about the paired data assumption? That's all you got.
Yeah.
They're linked because they are scores from the same person. Very good. So I assume the groups are linked because the scores are from the same person. Okay, so after we make that assumption, then we can go into the assumptions and conditions that we have been doing for a while now. All right, the next one I'm going to do is the independence assumption. Okay, what do you guys think here? Are you worried about independence? Okay, are we worried about that, right? So the statement that your said is perfectly correct. One student's, but I'm not going to say score, I'm going to say difference, right? I'm not like that much of a stickler, but really we care about the differences. So one student's difference in their scores will not affect another student's. Now, are we worried about that?
Yeah.
They could cheat, okay? Interesting. I've never really thought of like, why would I pay for a prep class but then cheat?
To cover it up. That's what the people did.
But the whole, fair enough, well, okay, but there's no incentive for these people to cheat. For the 30 people, why is there incentive for them to cheat? I mean, this is like, I know, but the idea is that this is more of a thing that the prep course or the prep program would want those scores, those differences to be higher, right? But in terms of like, when I enrolled in mine, there was no incentive for me to cheat, right? And I imagine that these are taken like at the site. You know, this is not necessarily a real SAT. Right? You guys are assuming it's the real SAT. I took multiple tests at their location. It was not a real SAT. I mean, it was, right? But it wasn't going to count. Because they want to know what your scores before, what your scores after, because they can use that to advertise.
Okay, what if they don't?
Why, yeah, I paid them.
What if they don't score it like the same exact way the SAT scores?
Great question. I have no idea, right? I do not have enough information to tell you that. I assume that they're scoring it the same way the SAT does. Otherwise, why are you preparing for the SAT? Okay. All right, let's just move on then. What if they have secrets? Okay, let's just go back. I regret even asking. One student's,
Wait, what was the answer?
exactly, difference
Oh, there you go.
in scores will not affect another's. Okay, so basically a statement that's saying that we think that the difference in scores for each student are independent. Okay? Now let's do the randomization condition. Does it say anything about random? Does it? Excellent. Random sample of 30 students. Nice. Okay, what about the 10% condition?
300.
All right, so what about that 300, Jarvis? That they're able to take their sample from? So let's see. There needs to be more than 300 students in their population. I put it in quotes, so I'm saying like, if this is like Kaplan test prep, they have more than 300 students that they're sampling from. I should say, the one that I did. Okay, how's everyone doing so far?
Great.
Great. Let's do the normal population assumption. Okay, so what do we have to assume here? What type of graph? Histogram, very good. You can take out the roughly, right? Because we're assuming it's normal. There you go. So we are assuming that if we had not just these 30 data values for these 30 students, but if we had all of them, whatever their population is, thousands of students, hundreds of thousands of students, I don't know how many this test program services, but if we had all of them and found their differences, and then I made a histogram with all those differences, it would look unimodal and symmetric. That's what we're assuming. Okay, so I am assuming, don't be mean.
Don't be mean.
Yeah, moderately linear.
That's me. I said that.
Oh, you did? Oh, well, I guess you're mean to yourself. I'm assuming that the population histogram of differences in scores would be normal. Okay, now I already told you guys that before you arrived, I went ahead, found the differences, so their second score minus their first score, all right? And I put it in Desmos and made a histogram. Shout out Desmos. I'm not on Twitter anymore, Desmos, so I know you miss me. Okay. Yeah, right, Desmos. My bad. They're so not going to. Okay, what do we think? What do we think? All right, so I put in those 30 differences, and there's the histogram. Do we think unimodal and roughly symmetric? Great, so then I'm not worried about my sample size. Stop it.
I thought you said
No, okay, so this is a thing I think, Catherine, this is a good question or a good thought. So Catherine was saying, I thought you told me it was not roughly symmetric. So there's two things happening here, Catherine. The first statement is for a histogram I don't have. All right, so I always think that that histogram is unimodal and symmetric, not roughly, like it's perfect, a perfectly symmetrical histogram. So I don't know that one. But this one I do have, and I just looked at it, and now I'd say it's unimodal and roughly symmetric. If you want to say symmetric, that's fine, right? I would just probably avoid, kind of like avoiding moderately linear, I would avoid using the word symmetric without roughly, because that is not perfectly symmetric. Do you agree? It is unimodal, one main hub. All right, it does look roughly symmetric. Pretty good? Okay, have you sketched that yet? All right, I'll leave it here so you can sketch it. Sketch it underneath the nearly normal condition. Again, make it small. It doesn't need to be a large sketch. A fairly small sketch is fine. Okay, then.
Tomorrow, guys.
Yes, 4th grade. And then we'll start the cookies. What cookies? These cookies.
That's why we're not yesterday.
These cookies. Famous Amos and Chips Ahoy. Yes, Leslie.
So it's not going to be defining parameters.
Good question. So the Kahoot, all the Kahoot, well, okay, I should have. The Kahoot is going to have, the majority of it is you read a paragraph, 2 to 3 sentences, so not much, and you have options of 1 sample t-test, 2 sample t-test, paired t-test. You got to choose which one you would do. You don't have to tell me the hypotheses, anything like that, but based on reading it, which one would you do? Now, I am going to have, just for fun, some questions where I put up symbols, and you've got to tell me what the symbols are. Hopefully, you'll be fine with that, right? Mu, Y bar, sigma, S, D. I don't know if D bar made the cut. All right, but we're going to use D bar. Okay, we're good? Everybody okay? All right. So you sketch the histogram. A key thing about when you do the nearly normal condition is after you sketch it, go ahead and write that you think the unimodal is roughly symmetric and unimodal. No, that's not what let me try again. Go ahead and write that the histogram is unimodal and roughly symmetric. Okay? Great. Good job. You are. Okay, so now what are we ready for? Before that, you're F.
I
use the
90%.
No, the I think. So I will now run the.
Okay.
Wait.
I'm losing. Just dropping like flies. Okay.
The condition having sense.
Yeah, it's a statement that the conditions are satisfied. That's it. That's all I was going for. All right, Bianca, even if she's not here, would have gotten that right. Okay. That's her thing. Okay, the conditions.
I think she'll watch this.
Do you think she will? Probably not right now since I haven't posted it. If she can watch it right now, then she should just be here. The conditions have been satisfied. Stop. So I will use a T model with how many degrees of freedom? Very good, Drew. 29 degrees of freedom. And run a paired T interval. All right, so who has any questions so far? Because so far we've done no math, and we've just said basically what we have to assume and what we're checking is all good to do the math. By the way, I don't know who it was in here. Someone told Pedro about my comment about calculus.
He heard it.
No, he said that he watched video evidence. I don't know who you are,
Probably subscribe.
It's true.
but I will find you.
It's true.
And when I find you, I'm not going to do anything. But I'll be
I
upset.
don't know.
But I'll know. Just know that I'll be hurting.
It's
What?
on YouTube.
Pedro came up to you and was
What do
like,
you expect?
what's this you talking about calculus? I don't know what you're talking about. He's like, I heard the video recording. I was like, it wasn't me. Okay, let's do the mechanics. So we have sample size is 30. Sample size. I should, next time, when I think of it, I'm going to wear my shirt that says, another day without using calculus. Okay, degrees of freedom, 29. Now, I went ahead also, because you guys know I love the Desmos, all right? I went ahead and found the mean and the standard deviation for these differences. Okay?
Is that 63.2?
It is 63.2, yes. 63.2 is the average difference from their second score minus their first score. And the standard deviation is 41.89. I guess we can only, since they're whole numbers, we can do 41.9. Let's do 41.9. Okay. So that's D bar is 63.2 points, and S subscript D for the differences was 41.9. I don't know, was it? Yes, it was. Excellent. Whew. Okay. We ready? Okay. So here's the formula for the confidence interval. D bar plus or minus. What comes next? T star. Nice. And now I can go ahead and put what as the subscript? 29, because that's the degrees of freedom. all right? So in this case, it's our sample size of 30 minus 1 times the standard error of D bar. The standard error of D bar is the standard deviation from our sample over the square root of the sample size. Okay, now a couple of things here. Okay, a couple of things. Number one, right, just be careful. A very common mistake, all right, this could happen to you on the test on April 1st. A lot of students will just forget that this is T-star. And do I know what T-star is? No, I don't know what T-star is, right? Even though this problem said a 90% confidence level, right? If I was using the normal model, I will be using 1.645. I'm not doing that because I don't know what it is yet, all right? MathCracker will tell you, or I can show you that applet again that we used a couple weeks ago to find it, all right? You'll have, all those links will be available to you. Okay, so I'm going to replace D bar with 63.2 plus or minus, I don't know yet, times the standard error, which is 41.9 over the square root of 30. Be careful, that's a good mistake, Jarvis. So make sure that that one is the sample size. Okay? So this is the sample size, not degrees of freedom. Everybody okay? All right, so let's go to MathCracker. All right, the sample mean was 63.2. Come on, you got this. Okay, 63.2. Okay, for the sample standard deviation, it was 41.9. Sample size is 30. And our level of confidence is 90, so I'm going to use 0.9. Everybody okay? Okay. Do you miss it? Do you miss it? Ad blocker, you know? Can't recommend it enough. All right, another potential ad, right? Gosh, oh, look at how fast it is without those ads. Okay. Now, do you guys see, where is it? I thought it was first. Where is it? There it is. I was looking for the T-star. All right, it says, based on what you provided, that they're trying to tell you, like, if you use 0.9, 90% confidence, then if you did a test, your alpha would be 0.1, okay? For degrees of freedom, we already knew that. And then this right here is what I'm going to replace with my T-star. Now, remember, with a normal model, what would it have been? 1.645. So it's not that far away, right? But it's still different. It's still not the same. 1.6. Chuck, let's argue. Right? 1.699. So excited. 1.699. So that's just one of those. I mean, you saw my brain already wanted to do 1.645. So just be careful. Use the correct T-star. Okay? So now I have 63.2 plus or minus. And I think this gives you the margin of error. Does it give you the margin of error? Yes, it does. Do you guys see the margin of error here where they subtracted and added? Right, that's the margin of error, 12.998. So I can get my interval, which is 50.2 and 76.2. Okay, and the very last thing before you're completely done is to statement. I am 90% confident that the average difference between after and before test scores is between 50.2 and 76.2 points. All right, now as you're writing that, and hopefully even as you wrote down just the interval without the statement, immediately what am I hoping your brain sees about that interval? What am I hoping that your brain is seeing about that interval? Well, the D bar is right in between. I agree. Right? It's about 13 away from both of them. But more importantly, there's something else about that interval you need to know. And what is not in that interval is 0. Ever see how 0 is not in that interval? All right? That tells me that I don't expect the average difference to be 0. So what can this test prep company say? They have evidence that it's going up. And then the person says, wait, how much does it go up by? I'm 90% confident it goes up by 50 to 75 points. Right? And if you guys do it, no, I'm just saying I'm trying to give a real world context to this, right? When you look at pamphlets or now this was back in my day, but websites, when they make these claims on their websites, that's what they're doing. They're using their data to make these claims. Okay? Say it again?
No.
Okay. Any questions on the interval? Everybody okay? Okay. Do you guys want to see how to use